Hello again, welcome to another lesson in geometry. Today we're covering section 7-4, similarity in right triangles. All right, so we have some vocabulary here. Underline the correct word to complete each sentence. So the altitude of a triangle is the segment from the vertex to the opposite side that is perpendicular to the opposite side. Okay, so here's any old given a triangle. Okay, so we take one of the vertices, I'll take the top one here, and we draw a cross to make it perpendicular. And this is the altitude. In grade school, 6, 7, 8, you guys always called that the height of the triangle. And you could do that from any one. And remember, sometimes the height of a triangle ends up falling outside of the triangle. Okay, so the altitude is the height of the triangle. So in an isosceles triangle, the altitude to the base divides the triangle into two congruent triangles. All right, so this is isosceles triangle here. And you can see the altitude drawn from C down to D, and it splits it into two congruent triangles. The left triangle in red should be congruent to the right triangle in blue. And you can do that by doing angle, side, angle. The side in between is the same in both, and we split this in half, okay, because that's what a perpendicular bisector does in an isosceles triangle. All right, so circle the altitude of triangle ABC. So we had triangle ABC, and they drew in the altitude here, and the altitude was CD. All right, geometric mean, this is new here. So definition, for any two positive numbers A and B, the geometric mean of A and B is found by doing A over X equals X over B, and X is going to be our geometric mean. So when we solve for X in this proportion, we get the geometric mean. So for example, the geometric mean of 4 and 10, well, we would set up the proportion 4 over X equals X over 10, and then we would solve it. So we get 40 equals X squared. And then you could do the square root of that, and you're going to get exactly 2 root 10. And if you need some help with figuring out how that turns into 2 root 10, we'll work on it a little bit in class next time. Okay? All right, so which proportion can you use to find the geometric mean of 5 and 15? So remember, the geometric mean, it's supposed to be the 5 over X equals X over 15, or it could have been 15 over X equals X over 5. So let's see if we can find one of those. Here we go. Choice C. 5 over X is X over 15. Underline the correct equation to complete each sentence. The geometric mean X of A and B is what? So let's try this. A over X equals X over B. Cross multiply here, we're going to get X squared equals AB, and then square root it. So X would be the square root of AB. That's going to be our first choice, not the second one. The geometric mean of 3 and 7. So that's 3 over X equals X over 7. So 21 is X squared, and then we'd square root that, so we get the square root of 21. And then circle the geometric mean of the square root of 3 and the square root of 3. So let's see here. The square root of 3 over X equals X over the square root of 3. So if we cross multiply, we get X squared equals 3. And then we could square root both sides to solve it, and we're going to get the square root of 3 back again. All right? So the geometric mean of a number in itself is always the same number. Okay, so let's see if that works for us. So 10 over X equals X over 10. If we cross multiplied, we would get 100 equals X squared. Square root, we're right back to the same number. Okay? All right, let's flip it over and see what's on page 2. On page 2 here, we have some key concepts that are very important for this unit. So theorem 7.3 and then corollaries 1 and 2. So theorem 7.3 says the altitude of the hypotenuse of a right triangle divides the right triangle into two triangles that are similar to the original triangle and also similar to each other. All right, so here is the hypotenuse, it goes from A to B, and we draw its height in, its altitude up to the right angle, okay? All right, so we can see now there's 3 triangles here. We have the original big triangle, which we'll do in blue, and it has a right angle right here. And then we have the little triangle that's split on this side, okay? This guy comes down here. Okay, he's similar to the big blue one. And then we have over here a green triangle, Okay, and he comes over here, and he's similar to the blue one, and the blue one and the red one are similar, and the red one and the green one are similar. So all three triangles are similar to each other. That means they have all angles congruent and all sides proportional. So we have three triangles, a little, a medium, and a big one here. Okay, that's formed each time. All right, then we have some corollaries based on those. So corollary 1 says the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. Okay, and this comes straight from the fact that these two triangles are similar to each other. So let's show what they're talking about in this one. The length of the altitude, that's the red part through the middle here, that goes to the right angle. It only works to the altitude that goes to the right angle, is the geometric mean of the two little short sides that are formed when it's cut. So this blue one and this green one. Okay, so that altitude cuts the hypotenuse into two parts. The two parts, okay, the altitude itself is the geometric mean of those two parts. Okay, so that's what this is saying over here. So CD, notice, is used twice. That's because that's the geo mean. And then we have the left side and the right side. All right. Corollary 2 to theorem 7.3 says the altitude of the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the whole hypotenuse and the little piece of the hypotenuse that's cut off on that side. Okay, so there's two ways that this can happen. If we look at this leg over here, AC, then AC is going to be the geometric mean. Notice it's used twice. Okay, of the whole hypotenuse. Okay, that's AB, and the little piece of the hypotenuse that's cut off on that same side as the leg. That's AD. Okay, and it works for the other side of the triangle also. So over here, CB is the leg that's touching the right angle on that side, so that's the geometric mean. And it's the geometric mean of the whole hypotenuse and the piece of the leg that's touching, or the piece of the hypotenuse that's touching the leg, cut off by that altitude. Okay? All right, so those are going to take a little bit of memorizing on your part, so you want to make some flashcards for them. All right, so triangle LMN is a right triangle with a right angle LMN. So there's our right angle over here. Okay, and NP is an altitude to the hypotenuse. Okay, so that's the height of the triangle coming from the hypotenuse. Complete the similarity statements below. So this says the big triangle is similar to, and we have it similar to, remember the medium triangle over here? And it's also going to be similar to the little triangle over there. Okay. Now in both the little and the medium triangle, the right angle is P, and in the big triangle, the right angle is N. So I know I need P to be last in both of these. Okay. In the big triangle, L is the little angle, and in the medium triangle, the blue one here, L is also the medium angle, so I'll put L first. However, in the red triangle, N is the little angle. Okay? And then the medium angle is going to be in the blue triangle, that would be N. And in the red triangle, that would be M. Okay? So we have L and P for the blue one. And I should probably put that in blue. And for the red one over here, we have NMP. Okay? And those match up with the big triangle, which was L and M. Okay. All right, so now we also know that this blue and red triangle are similar to each other, so we're going to write a similarity statement here. So LNP is going to be similar to NMP. Okay. Same places they go with the big triangle. All right, so use the triangle at the right to write corollary 1, 2, or for each proportion. All right, so we're going to figure out which piece we know. So in number 9, the geometric mean is the length A. A is one of the legs of the really big triangle, the original triangle. So that is corollary 2. That compares a leg to the hypotenuse and then the part of the hypotenuse that is cut off by the altitude on that side of the leg. Okay, so this is corollary 2. Okay. All right, and the second one, the geometric mean, is our M. M is the altitude of the original triangle, so that's corollary 1. Remember, the altitude of the original triangle cuts the bottom pieces into two things with a geometric mean there. So this is corollary 1. And then the last one, we have B, that's another leg of this one. So the geometric mean is a leg, so this is going to be corollary number 2. Okay. All right, let's flip it over and look at the next page where we show some applications of this. All right, problem 1 on the next page. Identify similar triangles. What similarity statement can you write relating the three triangles in the diagram? So the first thing we're asked is just what are the names of the triangles? So they give us one name. They say RPQ. RPQ is the big triangle, so we can write that one. And then we need to name the other two, so let's name the little one over here. We can call it whatever we want, so it doesn't have to match up just yet, so we'll call it PSQ. And then we have the the medium one over here, and we'll call that SRP. Okay. All right, write the three right angles. So I'm going to erase here so I can see my right angles a little better. In the big triangle, the right angle is QPR. Oh, there it is right there, RPQ. In the little triangle, the right angle is QSP. And in the medium triangle, the right angle is RSP. And then it says write the three smallest angles. In the big triangle, the smallest angle is QRP. That's this little one here. In the little triangle on the left, the smallest angle is QPS. And in the medium triangle, the smallest angle is once again QRP. Okay. All right, so use your answers in exercise 13 and 14 to write three similarity statements beginning with the vertex of the smallest angle in the right triangle and ending with the vertex of the right angle. All right, so RQP is the big one, and it began with the vertex of the smallest angle, which was R, and ended with the right angle, which is P. So we want to use the little triangle first, okay, the one on the left here. We want to begin with the smallest one, so that's QPS, so that smallest one's going to be P. And the right angle would be S, so the middle one's going to be Q. Okay, and then we have RQP again, the big one, and we're going to compare it to the right side. So this triangle over here. And the smallest angle in this one was R again. The right angle was S, so we put that on the end, and P has to go in the middle. Now, these two triangles are similar to each other, along with the first two are similar to each other. So this says the big and the littlest one on the left, and the big and the little one on the right, kind of the medium triangle, are similar to each other. So that means that by the transitive property, the little one on the left and the medium one on the right should be similar too. And we don't have to worry about what order to put them, because we know they already match up in the right order based upon they matched up in the right order with the big triangle. Okay, so PQS is similar to RPS. Okay, and problem number 2, we have finding the geometric mean. And in this case, we're just asked to find the geometric mean of 4 and 18. So we don't know what the geometric mean is. So we'll let x equal the geo mean. And that means x goes into the bottom left and the top right here. And then we want to find the geometric mean of 4 and 18. So those go in the top left and the bottom right. So we'll do our cross products. 4 times 18 makes 72. X times x is x squared. So then we're going to square root both sides. We get the square root of 72. We're only getting the positive square root here, so we're going to ignore the negative because the geometric mean only works for positive numbers. All right, and then we can simplify the square root. So that's really square root of 36 times the square root of 2. So that's 6 root 2. All right. Okay, problem number 3. We want to actually do some stuff with triangles for this. So in problem number 3 says, using the corollaries, what are the values of x and y in this triangle? So we had a right triangle with an altitude drawn from the hypotenuse, and it split the hypotenuse into 2 parts, 4 and 5. And we could use that to find all the other lengths if we wanted to. All right, so underline the correct word to complete each sentence. X is the length of the leg of the largest triangle, so use corollary number 2. Remember, corollary number 2 has to do with the leg as the value of X. Okay. And number 18, Y is the length of the altitude of the largest triangle, so we want to use corollary 1 so that we use the altitude as the geometric mean to find the value of Y. All right, so find the values of X and Y are found below. Just use justification for each step. So this is write a proportion here based upon which corollary we're using. Write a proportion. All right, and then we're going to do, so let's talk about our proportions here. So remember, the leg is the geometric mean of the short part of this and the long part of this, of the hypotenuse. So where it was cut off, that touches the leg, and then the whole hypotenuse. So the short part was 4, and then the whole hypotenuse was 4 plus 5. Okay, and then on this side, the altitude here is the geometric mean of the split part of our hypotenuse. So it splits our hypotenuse into 2 parts, 4 and 5, and that altitude is the geometric mean of 4 and 5. So that's why they put Y in both spots here and 4 and 5 in the other spots. All right, so here we're going to get our cross products for solving the proportion. This is just our algebra part. So 4 times 9 gives you 36, and x times x for x squared. And then we're going to square root both sides, only worrying about the positive square root. All right, and then we'd simplify the square root. Okay. All right, so here we get x equals square root of 36, but the square root of 36 is just 6. And on this side, we have y squared equals 20, 4 times 5 for 20. Square root both sides, we get the square root of 20. The square root of 20 is the same as the square root of 4 times the square root of 5, so that's 2 root 5. All right, let's flip it over. Okay, in problem number 4 here on the last page, we have finding a distance. And we have points A, B, and C are located so that AB is 20 inches. So that makes the big triangle, and we put a 20 on the AB length. Okay, and AB and BC are perpendicular. So that's why we have a right triangle. Point D is located on AC so that BD and AC are perpendicular. So we found the altitude of our right triangle drawn from the hypotenuse. And DC was 9 inches. So that gives us this 9 inches. Now if we look at our picture, we're missing a number in the description here that's on our picture. So they have a 16 inches for the length of AD. Okay, so you program a robot to move from A to D and pick up a plastic bottle at D. And then from point D, you must turn right and move to point B to put the bottle in the recycling bin. How far does the robot travel from D to B? All right, so they just have a magic 16 shows up in our picture, and they don't say where it comes from. So here's what they did. Okay, they knew that the leg of the hypotenuse was 20, and that was supposed to be the geometric mean of the whole hypotenuse. So I did 9 plus x, compared to the part of the hypotenuse that touched the leg. So that was x, the segment that touched the leg. So I did this proportion written from corollary number 2, and then I cross multiplied and solved it. And this involves some quadratics, which is why they kind of glossed over it, I think, and we can find out the length here is 16. Okay. All right, so we know the 16 part, and we want to find from D to B. So that's what we're looking for, is this piece, this X here. Okay, so let's put a check in all the stuff we know. So I know the length of the hypotenuse of ABC. This is check. It should be 25 long now. We did not know that before. I know the lengths of the segments of the hypotenuse ABC. This is a check. They are 9 and 16. I know the length of the altitude. No, we don't know that. And I can use corollary 1 to solve this problem. And this is yes, we can find that the altitude is the geometric mean of the 2 pieces of the bottom here. Okay, so the 2 segments of the hypotenuse. So we set up our proportion. The altitude is the geometric mean, so that goes in the bottom left and the top right. And it's the geometric mean of the 2 segments of the hypotenuse, so that's a 9 and a 16 here. If we cross multiply them, we get x squared is equal to 144. And then if we square root both sides, we get the square root of 144, which simplifies to a nice even 12 for the positive square root. So the distance from D to B the robot has to travel is 12 inches. All right. So this part here was a bit trickier. And if you have some questions, you can ask me in class, but you're going to probably have to start brushing up on your quadratics a little bit. All right. So lesson check. Do you understand? So this is a short lesson check, so let's go ahead and just go through it. Identify the following in triangle RST. So RST is the big triangle. What is the hypotenuse of the big triangle? Well, that's RT. That's the side across from the right angle. So that's this one. Okay. What are the segments of the hypotenuse? So what's that hypotenuse got broken into two segments by that altitude? So this is RP and PT. Okay. And the segment of the hypotenuse that is adjacent to the leg ST is going to be PT again. Okay. All right, that concludes our notes for the day. Check off the vocabulary words that you understand here. So we should be pretty good at geometric mean. Altitude, that's just the height of the triangle. And similarity, we're still working on. So if you're having some trouble with this, similarity of right triangles, if you can't see which parts go with the geometric mean for corollary 1 and 2, you want to go back and watch the video again. I'll see you in class next time.